So I think in India, some of those ideas are uh, actively being pursued in dozens and dozens of very exciting startups. And you yourself are the co-founder of some of those. Let's talk a little bit about two particularly, Agnikul and ePlane. So let's start with ePlane. What's ePlane all about, and why is it such a game changer?
Right. So ePlane, particularly when compared to others of its kind and around the world, is actually trying to configure a aircraft for the purpose. So one of the problems that I have with aerospace, largely, is that aerospace engineers actually are kind of like a cult, and because they do something really amazing and so on, so they feel
Did
like
you all hear that? Aerospace engineers do something amazing, and I believe it.
right, right. So, but they have a chip on the shoulder. So correspondingly, so there's always a problem associated with anything, right? There's a problem with pride. Okay, so the point essentially I have always felt is that the aerospace engineer would actually make a machine and then say, okay, voila, that is the machine. The customer has to actually figure out how to use it, right? And because they try to hype it up and they make it like such a novel thing or an aspirational thing, the customer has to adapt to the product, whereas in lots of other things the product actually, that's the real thing to do, right? So
Product evolves to fit customer demands and
absolutely
needs.
right. So this is a particular strain that is actually absent in the aerospace engineers DNA so far, and we are trying to
Let
correct that
me
at the
poke a hole in that. The argument I've heard from the aerospace engineering side is that safety is paramount. And therefore, we are very reluctant to change, and you customers have to fit in. Why is it not the right argument to make?
that's perfectly fine. We are nobody argues against safety, right? But question is like, where do you want the plane to land? Where do you want to actually go catch the plane? Right? How much time do you have to actually spend to get there? So if you now think about what's happening in the large aerospace segments, for example, Airbus A380 actually is the largest aircraft ever built, and it has had the shortest production run, unfortunately, which essentially means that people want more on-demand transportation, right? They are so there is so you now hear this phrase word called mobility more often than transportation. So it's not like a 2020s fad to use the word mobility. So the distinction between mobility and transportation, fundamentally aerospace engineers will have to actually come back to the ground and say, hey, we are actually in the business of moving people and goods, and we are just one of those ways of doing this, right? We might be able to do this all the way up to going to space, but still we are actually moving people and goods. That's what it's all about, right? So mobility is actually more user centric on where somebody wants to actually go from place A to place B, right? And how are they going to accomplish this, rather than transportation being like mode centric. So if you want to be part of the 21st century, at ePlane, we actually think about whether can I land on your rooftop and pick you up from where you are and land where you want to go to, right? Instead of you having to go to an airport or a what we now are beginning to call as a vertiport, and then that's a ground journey that you have to do, and then you have to fly, and then you have to do another ground journey from the vertiport you landed to and then to the final destination. All of these things actually rob the charm of decreasing the time it takes for you to get there. The next thing is cost, right? So people always associate aerospace engineering with being super expensive. The question is, can we disrupt the cost structure to make it comparable to like a conventional Uber, right? So these are a couple of things that we started doing, configuring a aircraft to the needs of the particular application, namely the air taxi. How can I actually do multiple short trips in a single charge with a very, very compact wingspan that can land anywhere, like a typical taxi? So today's planes are not typical taxis, and that's what we are trying to do at ePlane.
So you've said this eVTOL many times. So explain what VTOL is and what is eVTOL.
Correct. So VTOL essentially stands for vertical takeoff and landing. So a helicopter is, for example, a VTOL machine, right? It takes off vertically. But today's class of VTOLs are a hybrid between vertical takeoff and fixed wing. So the other jargon that we have is fixed wing versus rotary wing. Helicopters are rotary wing devices, whereas planes are fixed wing devices. So is there a way by which I can actually put a plane and a helicopter together? Is the point. But we have now moved away from the helicopter, which is typically a single rotor configuration, to a multi-rotor configuration, which we very commonly see in drones, and that allows us enough amount of redundancy and the safety that you are actually talking about in the configuration itself. So safety is not about going through security checks and wearing your seat belts. It's actually about whether the plane will make sure that it's up in the air all the time when you want it to be, and land safely. So in aerospace, we have the dictum takeoff is optional, landing is mandatory. So you want to make sure that you land when you once you take off. That means that the aircraft has to actually be safe by itself. That's where a multicopter allows you to do so. But now we want to actually get a longer distance, better mileage for the batteries that you spend. You actually have to make it electric to be sustainable as well as cost effective.
And that's
And
the E part of
that's the
eVTOL.
E part of the eVTOL. So all put together, we now have a new breed of aircraft called eVTOLs that are a blend between fixed wing and multicopter, powered by electric batteries.